So I'm going to start with the unit, okay? And the unit for a concentration is moles. It's written like this at GCSE, at Key Stage 3. Not at A level, it's a different, we write it properly then. But even then, it's only a slight difference. Moles backslash dm cubed. So first of all, so if you look at the questions here, there's a question here. Look, there you go. Right. Where else have we got? Conc. Where is it given conc? That's the unit. Right, you can say 0.1 moles per dm cubed, and the unit is given to you in an exam, in a test, in a research paper. The unit is always given to you. And what does this mean? Okay, now what this backslash means is it's like writing a fraction on a single line. You can't write a fraction on a single line, not in a traditional way, but we can translate into how we see fractions. What this actually means, if I write it as a fraction, is moles. And the kind of language you use is over dm cubed. All right. Well, I kind of see it in a different way. It is moles, and this sign means, well, I'm going to divide it. So the word over doesn't really tell me which mathematical operation am I doing. And that means it doesn't tell me whether I'm adding, times in, divide. What am I doing? All right. So in this, when I see moles backslash dm cubed, and this is, let's just change color, this is the unit for concentration that you will always get. All right. It actually means moles over dm cubed. I don't say it that way. I say moles divided by dm cubed. All right. So this, believe it or not, when you look at the unit, that's the equation. That's the formula. That's the formula for working out concentration. So, well, what do I mean by this? So, like in that question there, it said you have a 0.01 moles per dm cubed. That's your concentration. So, what does it mean? So, what it means is to work out my concentration, I take my moles and divide it by dm cubed. What's dm cubed? Well, this is the unit for volume. When I was your age, the unit for volume, and we still use it, is litres. We don't use that anymore, right? In science, we now use the unit. Well, we're still doing a lot of things like medicine and stuff, but in science proper, we use the unit dm cubed, right? So 1 litre equals 1 dm cubed. And I don't actually think of dm cubed. I don't like dm cubed. And the reason being is I was taught in litres when I was your age. So for me, a litre is 1,000 cm cubed. Right? So that's what I wanted to talk to you about today in terms of ideas. I expect you to understand what I said, but not be able to use it yet. Not for it to be fluent. And that's hopefully over the next few years, you become more and more fluent at thinking, look, the unit's telling me that, and I can do that. So I hope it does. And for some of you, and so units are very, very powerful. Now, what you'll see over here is within concentration, moles per dm cubed. You can see the unit, and you can see it moles divided by volume in dm cubed. Now, this is exceptionally important. Your volume must be in dm cubed, and the way you change cm cubed to dm cubed is divide by 1,000. Right. So when I look at question 1, calculate the concentration of following solutions in moles backslash divided by dm cubed. This is not dm cubed. Cm cubed is the first thing I'm going to do is divide that by 1,000. Oh, I picked the wrong one. I was doing that one. But anyway, the point still stands. If you're in cm cubed, divide by 1,000. All right. Now, this is a comprehension idea, understand, get that round your nugget kind of thing. Now, the way to use it is twofold. You can use the formula. I like this. Now, this is the thing. This is a very personal thing. I love the formula. However, I have students, even at A level, who like to use the triangle. And I'll show you how to do it both ways. All right. So, first things first. I'm going to do question 1A. And I'm going to do question 2A. but I'm not going to do question 3 and question 4. These question 4 and question 5, these are all yours. You got to think about it. You got to problem solve. So the first 6 you should find meh. But question 3 kind of gets a little bit, all right. What do I understand? And I was having this conversation with your one of my year 13s who's doing maths, English, and something else. I can't remember. I think it's art or history. She's in a very interesting mix of A levels. And I said, believe it or not, maths, science, you have to be better at reading than A level English. In biology, especially, is a tier 3 language, what we call a tier 3 language. Everything you need to do question 3 is up here, but I'm not telling you because I want you to develop that ability to read. All right. And read is not the same as recite. Most people say the words but don't get it. All right. But anyway, let's get back to question 1 here. Calculate the conc. I'm working out conc. All right. So which one shall I use? Let's use this one. Well, this tells me for concentrations, do moles divided by volume. Volume must be dm cubed. This is not dm cubed. I'm going to divide it by 1,000. That gives me a concentration, a volume in dm cubed of 0.2 dm cubed. Do that with a calculator. Lay your work out neatly. That's before I've used the formula. The formula says number of moles, n, I use n for number of moles, divided by volume in dm cubed. All right, fine. Number of moles is 0.1. They've been very nice. They've given to me number of moles, divided by volume 0.2 in dm cubed. And this, you pop that in your calculator, and it gives you 0.5 moles per dm cubed. You've got to write your units, because hopefully I've given you an idea of how important units are. All right, so that's that question done. So like this one, calculate the number of moles in the following solution. So in a test scenario, in an exam, calculate the number of moles. I'm working out the number of moles. I've been given 100 cm cubed. This is my volume. I don't like it. It's not in dm cubed. And this, moles per dm cubed, is my concentration. All right. So straight away, I'll look at the 100 cm cubed. I'm going, oh, got to divide that by 1,000. So step 1, before I've even attempted to answer the question, I've divided my volume by 1,000 to give me volume of 0.1 dm cubed. Okay. So what do they want me to find? Was it calculate the number of moles? I've got concentration and now I've got volume as well. All right. So the formula is concentration equals moles divided by volume. Well, I want to find moles. The question is asking me to find moles. It's giving me concentration and it's giving me volume. So I need to rearrange it. I need to get rid of this. This is divide by volume. The opposite divide by volume is times by volume. I will times both sides by volume. So this gives me moles equals concentration times volume. My concentration was given to me 0.2 moles per dm cubed. That's concentration. Times volume. And here's the volume in dm cubed, 0.1. I think I can be 0.02 moles. Use a calculator. This is tricky to start with. You've got to give it a go. All right. How do I do exactly the same questions using the triangle? Shut up, it's the last time I'm saying it. Now, using the triangle, and some people like it. So if I'm doing question 1, calculate the concentration. I won't, do you know what? Let's change. Let's change to pink. Calculate the concentration. All right. That's not pink. Oh, that's been a bit strange. Can't get to pink. Can I go to pink? Yeah, I got to pink. All right. So we do this question. Calculate the concentration of the following solution in moles per dm cubed. I want concentration, so you cover concentration. And it says, right, I got to do moles on the top divided by volume. Brilliant. So I do moles divided by volume, exactly like we did before, moles divided by volume. But instead of using a formula, use a triangle. For question 2, we had to rearrange and we got to concentration times volume. But if you like the triangle, it says, well, how many moles have I got? So what you do is you cover moles. Right? So you go, I'm going to cover moles with my thumb. So what am I left with? Concentration. It's next to volume, and these are being times. And that's it. All right, you've got to give it a go. All right. Now, what I'm going to do, I'm going to do two things. I'm just going to take this and I'm going to paste it underneath. Oh, we're not doing titration, so I don't think we'll get that far. Let me just get rid of titration. I'm going to paste it. I'll deal with that later. I'm going to paste it underneath. All right. So what I want you to do, I've got my example up there. You've got a video, and a really important thing, when you're doing something that looks weird, and this will look weird to a lot of you, try doing the exact same questions I've just done. Lay it out properly. See if you get the same answer. Go back to the video, go back to my working out on top and think, do you know what? I almost was there, but... Okie dokie. God, I've been talking for 11 minutes. That's too long.